let's go over chapter 1, chapter 11, the remaining challenge problems, and then we will talk about maybe finish chapter 12 and see if we can get into chapter 13. Okay. 11. Okay, so challenge. Yeah, so last time we were at here, 11:43. Okay, just as usual, if you have any idea, you let me know, okay? We need to review something if you don't know what to do. Basically, we have a regular polygon. Interior angles, each interior angle is 168 degrees. The perimeter is 120. What is the side length? It's a regular polygon, right? So obviously, we need to find what? To find the side length, we need to know what about this polygon. Recently, I found that a better way to have interactions with my students is that, guys, what we call in psychology, we actually call it the means end analysis. Means end analysis. Okay, what it means is that means ways, means methods, right? Okay, and means what you want to, well, what is your goal? What is your end? What is your goal status? Okay, so in doing every question, guys, I want you to always to analyze this. You want to know what you want, and you're gonna see what kind of methods you're gonna use. What is the means? Okay. So can anyone tell me what is the thing we want here? To get a side length, what is our goal? We are given perimeter, and it's a regular polygon, so it should be very simple. What do we need? And how do we get it? Jerry, any idea?
You need to find the other angles.
Other angle. Because we need to find what? We need to find the number of sides, right? Okay. So Emma, Jerry, I think that should make sense. It's a regular polygon. You know the perimeter. You want to find the side length. You need to know the number of sides. Perimeter divided by number of sides is one of the side, right? So you want to know how many sides. N-sided polygon. Let's say you want to find what the n. So how do we know the number of sides? Albert said he needs to find the other angle. And that's actually something I want to review today. What is so-called other angle, Albert? What is
Exterior?
exterior? Yes, very good. So I drew part of the polygon here, right? But I don't know how many sides, so I couldn't finish. I'm gonna just draw a part of it. Emma, Jerry, right? Okay, that makes sense. Yeah, Albert said we can find the other angle, which is the exterior angle. So we extend one of the side. Then we go here. That's 180 minus is just 12 degrees. So that's the exterior angle. So why do we want to find the exterior angle? We have learned these formulas before, if you guys remember. The sum of interior angles of a polygon or the sum of exterior angles of a polygon. Does anyone remember anything about these? The sum of exterior angles, the sum of interior angles?那么你有印象吗？多边形的内角和外角和我们之前学过的多少啊？ 你看你点头，那你能说一下不？
You
看看，
if you add all the exterior angles of this polygon, it adds up to 360.
Yeah, very good. What about the sum of interior?
Also 360.
But you have many sides. It's an n-sided polygon, right? It wouldn't just be 360. Think about a polygon like
Is it 100? Is it 180 times the number of sides divided by -2?
very good. N minus 2 times 180 degrees. Okay, do you guys remember the proof? I'm not sure, but if it's okay if you forget a proof, but please remember the formulas, right? Because something we learned is not just for that unit, and what is past is past. It's not like that, okay? If you study for math competition, you need to remember these. So you accumulate your knowledge, right? Accumulate, okay? Yeah. Like this. About a proof, just briefly mention it. Does anyone remember how to prove these? Drawing triangles, remember? Say that you have a hexagon. How do you know the sum of interior angles? Well, you can divide it into 4 triangles, you see? Each triangle has an interior sum of 180. So 1, 2, 3, 4, 4 times 180, done. Remember, Jerry, Emma? Emma, 你想起来没有？Emma，这个就公式啊。刚刚你看一下没反应过来，你要把它记住，好吧？Okay. Yeah. So if you have n sides, you can only divide it to n minus 2 triangles. You can give it a try. It's always like that, right? So that's why the interior sum is n minus 2 times 180. Okay, make sense? Emma, make sense 吧？你自己可以试一下，不管你几边形，你就这样分三角形，你只能分出来 n 减2个，6边形就有4个，10边形呢就有8个。Okay. What about the sum of exterior? The sum of exterior is like this, guys. Notice that for any interior angle, if I extend it, I can get an exterior, right? If I extend here, you get an exterior. The inside is called interior, and this part is the interior, right? We can see that the sum of each pair of interior exterior is always 180. Here is 180, right? The sum of interior and exterior is always going to be 180, right? It's by definition because you get the exterior angle by, well, extending the line. So interior angle, exterior angle, they have to be on the same line, right? It's 180 degrees. I think that everyone agrees. Yeah, okay, good. If that's the case, say that you have n sides. You have n sides. Then that means if we add n interior angles and n exterior angles, I add all of them, I simply just get 180 degrees times n, right? Because it's an n-sided polygon. So you have n interior angles, you have n exterior angles. If you add them, you just get 180 times n, right? Each interior and exterior is 180. Okay? And the sum of interior is n minus 2 times 180. And that definitely tells you the remaining part is 2 times 180, and this has to be the sum of exterior. See if that makes sense? Okay, the sum of interior and exterior. Very simple, n size, right? N times 180. And n minus 2 times 180 is the sum of interior. So you do a subtraction, you get the sum of exterior. 2 times 180, 360 degrees. Okay, Jerry, does that make sense? No? Yeah? Okay. Emma, 你明白了吗？没问题吧？那 n 条边嘛，对不对？你一延长就是一个外角，那内外角之和肯定180，n 个边全部加一块就是 n 个180，对吧？内角和呢，我刚刚说的是 n 减2乘180，画三角形画出来了嘛？那你一减，那 n 个180减 n 减2个180，肯定是俩180，对不对？这俩180那只能是外角和了，所以外角和永远是2乘180嘛，就这么简单一个证明啊。Okay, if there's no problem, then we'll continue. So from these two formulas, you will see that if you know the interior angle, you can actually use this to find it. But it's a little bit hard because this is only the sum of interior. So that means if you divide it by n, you can get the degree measure of each interior, right? Okay, in this case, you're gonna let it be 168. Does it make sense? Sum of interior divided by n. That's for each interior angle. And in this case, it's 168, so you can solve for n. Okay, but this is obviously too hard. If you use the sum of exterior, it's very simple. The sum of exterior is always 360, right? And here, you know one of the exterior angle is 12. So you just do a division and you will find the number of sides. See if that makes sense? And we found that it is a 30-sided polygon.
I
Any
found the
question?
final answer.
Yeah. What is the final answer?
Each side length is 4 centimeters.
Yes, very good. You see, it's very simple. Okay. Does that make sense? 来嘛，看有没有疑问？你要用外角和除以每一个外角的度数，就知道几条边了，对不对？因为你12度是外角，对吧？你有几个边就有几个外角，对不对？每个边是一个外角嘛，对吧？所以用外角和360除以这个12，直接得到这个多边形的这个边的个数了，一共是30边形。那每个边一共是120嘛，120除以3 120 centimeters divided by 30. Each side it measures 4 centimeters. Okay, Albert, any question? Emma?
Wait, so it's like the exterior angles divided by one exterior angle and get the number of sides.
Yes.
Oh.
The sum of exterior angles divided by one of the exterior angle gives you the number of sides. Does it make sense to you, Albert?
Yeah.
Yeah, okay, good. Yeah, because for each side you have one exterior angle, right? N sides you're gonna have n exterior angles. Basically, n is the number of sides. It is also the number of exterior angles, right? So you know the sum of exterior angles. You know each exterior angle. You do a division. You're gonna find a number of exterior angles. Then the number of exterior angles is the number of sides. Each side has an exterior angle, right? Yeah. Okay, so this is by far the easiest way to find the number of sides of a polygon. Okay, guys. So if you ever see any question and in that question you need to find the number of sides, you try to find the exterior angle. If you can find the exterior angle, do a division. That's number of sides. That's the easiest way. Okay. If you use sum of interior, it can take some time because you're going to do divided by n and equals something you're going to solve for an equation. It's not as fast as this. Okay. Let's just write it down. Sum of exterior angles divided by an exterior angle, you get number of sides. Number of sides. Okay. And the sum, by the way, is always 360. Should be 360 degrees divided by one of the exterior angles. Okay. All right. Next. In a quadrilateral ABCD, each of the sizes is an integer. AD equals to BC, and we're given two ratios, and we're gonna find the smallest possible perimeter of a quadrilateral. So instead of saying that this is a geometry question, you can actually say this is more of a ratio question. Okay, so you can draw a diagram, but the diagram, in my opinion, doesn't really matter that much. Just a random one, because in essence it's actually just a ratio problem. Okay, but we can draw one. So let's see. We are given that AD equals to BC. So these two are equal. And we're given two ratios. Any idea to start with? When you see two equal sides and some ratios, what is the go-to step? There is only one possible way when you see this kind of conditions. What do you do? And you're looking for the perimeter. That means you have to figure out one of the side length, right? If you figure out one side length and you have those ratios, then you can figure out all the other side lengths, right? So how do we figure out one of the side lengths? I need a starting step. How do we start? Anyone? It's not hard. Emma, 来，你觉得这道题可以怎么开始？我知道你没做，但是没关系，你看看第一步，至少是你必须得知道。而且我觉得我们学了这么久啊，人人都应该知道第一步，因为这是 ratio 的题嘛，我们学过 ratio 的啊。在 ratio 题里面给了 ratio，给了这些东西，你要求他们，对不对？怎么做啊？第一步干什么？要么你可以告诉我吗？你知道吗？就是还是说你完全也不知道第一步是干什么呢？
嗯，
不太知道。
可以再想。
好，没关系，那你先想一下。我问 Jerry 和 Albert。Jerry, Albert, any idea to start with? Again, it's a ratio, right? You need to figure out the side lengths. You know the ratio between them?
Would we set x?
Exactly. Very good. Let x be something, right? Jerry, did you think about that? Yeah, I think you should, right? Emma, 明白了吗？设 x，别忘了啊。In ratio problems, we always set x, right? So think about this. In this case, you have two equal sides. Obviously, you're gonna let them be x, right? If you let them be x, then you can use the ratio to figure out other side lengths using the same x, right? So let's give it a try. Let's say this is x, this is x. What about AB? We have a ratio. How do we write it? Anyone? How do we deal with the ratio? You're gonna change it into a fraction, right, guys? Okay, I'm gonna do an example. So AB to AD. Let's change it to a fraction. AB over, what is AD? X.
5.
5. No, X, right? That's 2 to 5. 2 to 5 is later. It's X, right, guys? That's why we set it to be X. So you can use X here. And you can use X to express for AB. Okay, Emma, Jerry, right? Makes sense? So AB to AD is AB to X, and that's 2 to 5. So what is AB? Emma, 这个应该会吧？你看看 ，AB 除以 X 等于它，那 AB 是几啊？这个也要想吗？
就是突然有点
那你像
大
你
脑内开机。
6除以2是3，你怎么得到这个6？除法变乘法嘛，把2乘过去，3乘2，对不对？所以这个地方你要求 AB 是把 x 乘过去啊，
是的。
想起来了吗？OK，也就是说等式两边都乘 x。对，我也感觉你应该是宕机了，还没开机是吧？今天都下午了，都还没开机啊。OK，Albert, Jerry, that makes sense, right? You just time x, yeah, time both sides by x, and cancels. So AB is 2 over 5 times x, right? So let's label it 2 over 5 times x. Okay, any questions so far? You see, it's very simple. Suppose x, and then use x to express the other sides because you're given ratios. So whenever we're given ratios, we set x and figure out the other part. Make sense? OK，Emma 永远记住啊，比例题永远都是 x，你设一个 x 嘛，其他的 x 都出来了，不是很好吗？对不对？OK，what about AD and CD? Can anyone tell me what to do? Jerry, Albert, Emma, anyone? Give it a try. How do I write this into a fraction and do a similar maneuver? AD to CD, anyone? Yeah, Jerry. AD to CD. We change it to a fraction, right? What is AD?
What?
Oh, we are doing this, right, Jerry? This part. AD to CD is 324. I'm gonna write it into a fraction, right? How do we write it into a fraction? It's AD over CD, correct? And what is AD? X. Yeah. So we write, what do we write?
X over CD,
Good. Equals?
3/4.
Yeah, very nice. And then we're gonna find what a CD is, right? How do we figure out what CD is?
Multiply both sides by 4.
By 4. Yeah. So you can time by 4, but still CD is in the denominator part, right? Okay, you can do a cross multiplication, remember?
Oh, yeah.
Yeah, okay. About this, I'm gonna maybe talk about this here. Okay, guys, I'm seeing a problem that you see for the first equation, it's very easy to manipulate, right? Because your desired quantity, which is AB, is on the numerator side, right? Is on top, and that means you just need to time by x. You can isolate it. Okay. I see that some students have problem with the desired quantity at in the denominator side. Okay. In this case, Jerry, you will notice that no matter what you do, CD is always on the bottom. And that means if you want to isolate it, it's not possible. Okay. So you're gonna first, like, our goal is to get it from the denominator and move it to the numerator. That's the best, right? So to do that, we can say we time by CD, actually. See, we time by CD, time both sides by CD, and that way you cancel. You will get x equals to 3/4 CD. You see? And now CD becomes the numerator. It's actually 3 CD/4, right? So CD is here. And then we don't want a 3/4 CD. We want just 1 times CD, right? So we're gonna change this 3/4 into 1. How do we make it a 1?
Times both sides by 4.
Over 3. Time is reciprocal. Remember, reciprocal brings a number to 1, right? So we time the reciprocal of 3/4, which is 4/3. We time it to both sides. They cancel, you get 1. In the end, you get 4/3x. So that's what CD is. Okay, so Jerry Albert, have a look at it and see if that makes sense. 要么你看一下这个地方。那么，要么你看这个地方我们在干什么？就是刚刚第一个 ratio 是根据题目我就写出来的，ratio 变分数，应该还记得吧？我们第一个里面求的是 AB，第一个这个里面的 AB 在分子上面，在上面啊，所以很好求，因为我把分母乘过去就结束了，对不对？但是你看第二个 case 啊，第二个 case 这个 fraction 也是根据题目写出来了，题目的 CD 在底下，我没有办法，对不对？我只能写下面。那怎么办呢？我可以把 CD 乘到另外一边去。乘完了之后呢，再把这个数字啊，CD 前面这个数字给它干掉，怎么干掉呢？就乘以它的 reciprocal，记得吧？乘以 reciprocal 变1嘛，所以这样子的话就能把它解出来，OK 吧？Make sense 吗？Right. Okay, Jerry. Any question? Okay, good. Let's discuss another way. So this is obviously well, this obviously works, but in my opinion, it's not the best way, right? You have time by CD. You're gonna think about reciprocals and stuff, right? For some students, it can be hard, but I mean, for math competition, this shouldn't be hard at all for you guys. Okay, if you find this hard, maybe you need to think more about school math, okay, instead of competition. All right, but we do have other ways. So what are the other ways? Well, we did mention cross multiplication, right, guys? Always remember a fraction equals to a fraction. You can do cross multiplication. And the idea, the rationale for cross multiplication is just to time both denominators to both sides like this, right? Do you guys remember? Time both denominators to both sides so that you cancel out CD, you cancel the 4, you basically just get 4x equals to 3 times CD, which is a cross multiplication here. See, 3 times CD, x times 4。好，Emma 这个还记得吧？分数等于分数，交叉相乘嘛，对不对？这也是可以嘛，交叉相乘一下做出来了，right? Okay, and once you get this, obviously divided by 3, so CD is 4x over 3. See, same answer. Another way. But they're basically the same way, okay? Because they're basically the same. Cross multiplication, or if you know what to do, you can do this, okay? And a third way, guys, you can always take a reciprocal of both sides. This is something I haven't really talked about in the past, okay? Again, you need to do the same operation on both sides of the equation, right? You want to do the same operation on both sides of the equation. So I can actually take a reciprocal of both sides, right? I take a reciprocal, so I do this. Reciprocal. If I take a reciprocal, I bring both sides into a reciprocal, I just flip it, right? CD over x, 4 over 3. Once I flip it, it becomes the first equation we see today. So CD is time by x, 4 over 3 times x. Same answer. Okay, so choose one you like. 大家看有没有疑问啊？Emma，你可以直接通过想两边应该乘啥呢，把它想出来，也可以通过交叉相乘想出来，还有一个就是可以通过两边都取倒数，倒一下，再把分母一乘，也可以看出来。我个人感觉最后这个比较简单啊，或者 cross multiplication 也很简单。好吧，第一个反而最难想的，因为这第一个需要比较，就是对这个解方程非常非常的，对吧？了解才可以啊。再看看 Emma 有没有想法，如果觉得没问题，你要把这些方法记住啊，以后要知道这东西怎么处理，对吧？你看我们越往后学，后面的这些题就需要前面的知识，你前面知识如果不记得，你后面题肯定是越来越难做，好吧？Okay, Jerry, any question, Albert?
Does this only work on fractions, like choose both sides fractions?
Yeah, it's because you're taking a reciprocal usually is something you do on both sides being fractions and when you want to flip one of the fractions. If you want to flip it, you take a reciprocal. But even if one side is not a fraction, that's fine. Say x over CD is 4, that's okay. You can still flip it and you also flip the other side and you time the x. You can still get it, right? Okay, just take a reciprocal. Whenever necessary, whenever you feel like it can help you, you can take a reciprocal. Okay, so there's just some manipulations you can do. You use it properly. Like you decide when to use it. Okay, but in the end, CD is 4x over 3. So let's label it 4 over 3x. Okay, now I think that's the end of this question. I have labeled all four sides. How do I determine the smallest possible perimeter of the quadrilateral? Now, obviously, if you want the smallest possible perimeter, you want to get the smallest possible x, right? So what is the smallest possible x here? How do we know? Anyone? What is the condition on x so that we can minimize it? Think about this. If there's no restriction at all, x can be any number. If I want to make it smallest, x can be, say, 0.001, right? Or even 0.000000001. If that's the case, that's maybe the answer is just 0 or 0 point a bunch of 01. That doesn't make sense, right? So read the question and see which part of the question gives us some restrictions on x so that we can determine it. Where is this restriction in the question? 那么你明白意思吗？这道题它要找最短的周长，对不对？那最短周长肯定把 x 取个最小值，对吧？但问题是 x 想取谁取谁啊，对不对？那我取个0.00001不就完了吗？那四边加一块还是0，就除非小到看不见，对吧？那我这样肯定不对嘛，这道题肯定不是这么做的，对不对？所以这道题肯定有个条件，它限制了 x，你才能使得就是说我找到个所谓的最小值。 这个条件在哪儿？我现在就问。It's not about math, guys. Where's the condition? Does anyone see it? If you don't see it, you read the question, okay? It's in the first line, first row.
AD must equal BC.
Well, AD is BC, X and X. They are equal. If X is 0.01, then this is 0.01, right? That's not the condition that restricts it. What is the sentence before this? What does this say, guys?
It must be an integer. The
Each
length.
side, right? Every side is an integer. Doesn't this restrain what X we can be, right? Say X couldn't be 0.01 now because each side has to be an integer. Jerry, right? Emma? Emma 看到吗？这是不是条件啊？ Okay, so that's why we couldn't just say X could be any number. Okay? Because each side is an integer. Now, AD, BC, they are just X. So let's say X is 1. They're good. But the other two sides have to be integers too, right? Okay, I think that's the answer. What is the lowest value of X that could make both values here integers? That shouldn't be too hard. Anyone? This is an integer. You want this to be an integer. This notation just means it's an integer, okay? We'll talk about this in the future. This is just a notation. Anyone? Integer, integer. You're gonna time it by 2 over 5. You're gonna time it by 4 over 3. They're still integers.
You can multiply 2 over 5x by 3 and 4 over 3 by, so 4 over 3x by 5.
Why do you want to time 4 over 3x by 5? Or is it... Did I misunderstand you? You want to do 4 over 3 times 5? What we want to do here, Jerry, is that we want both numbers to be integers, right? So let's just maybe think about 1. Let's just look at this. 4 over 3x is an integer. What is the requirement for x? Say x is 1. X is 2. Are they integers? 1 times 4 over 3. 2 times 4 over 3. You only get 4 over 3 or 8 over 3, right? So they are not integers, right? Shouldn't be too hard, guys. How do you make this an integer? What is the possible values of x that could make this an
3.
integer? 3. Very good, right? The denominator is 3. If you want this to be an integer, then that means x has to cancel out with that 3 somehow, correct? And that simply means x is a multiple of 3, right? Yeah, okay, I see Jerry, Emma, Jerry, Albert makes sense, right? Emma, make sense 吗？对吧？你要是整数，很明显 x 也是3的倍数，要 cancel out 的嘛。Okay? All right. So this means that 3 divides x. If you guys remember this notation, okay, 3 divides x. Doesn't divide is like this, right? 3 divides x. X is a multiple of 3. What about here?
Times 5.
Yeah, x is a multiple of 5. You want the lowest possible number. What is the lowest possible number?
15.
15. Least common multiple, right? So x is 15. Does that make sense, guys? You put it back in, you was check that this is 15, this is 15, this is 15 divided by 5, 3 times 2, 6, and this is 5 times 4, 20. There we go. All 4 are integers. If you want to find a perimeter, add all of them up, 56. The answer is 56, okay? Any question? Is it hard? It's not that hard, right? If you suppose x and just get the fractions out and think about least common multiple, that's it. So you see, it's combination of previous facts that we learned. Okay, and you will see that in this question, the diagram is not that useful. You don't actually need a diagram. In this question, you just need to suppose both sides to be x and work on the ratios. Without a diagram, you can still write down the ratios, right? Doesn't matter. And once you write down ratios, solve for AB, solve for CD, you get those fractions. And you're gonna notice that it actually says integer. See? No one noticed this. If you didn't notice this, you couldn't solve this question, okay? So notice the condition, and once you figure out all four sides, you're gonna think, how can I make them integers? Okay, it's just a fraction, shouldn't be too hard. You will see that they're, well, x has to be a multiple of 3 and 5, so it's 15 for the smallest possible value, and there we go, okay? Yeah. So instead of a geometry question, this is really a ratio question. And with some basic number theory, just least common multiple, right? Very basic number theory. Okay. 有没有什么问题 Emma? Okay, Jerry Albert. All right. If there's no problem, gonna move on. This is also an easy one, 11.45. Just a property of regular hexagon. You guys need to know. A, B, C, D, E, F, regular hexagon. Let's draw it. To draw a regular hexagon, when you label it, you're gonna label it in like in a direction. You can do counterclockwise, you can do clockwise, but you have to write down all letters in a row, okay? In a row. A, B, C, D, E, F. Now we know that AD is 16. Find a perimeter. Does anyone have any idea? It's just a very simple property of regular hexagon. What property? If you connect all these longest diagonals, okay, by the way, they're what we call longest diagonals here, okay, because you have a shorter diagonal. For example, you can AC and AE, they are shorter than these longest diagonals, okay? If you connect all of these, Jerry, what do you have?
The perimeter is 48.
Yeah. We will see six little triangles here, right? What are these triangles? What
A
type?
6.
Equilateral.
Equilateral, right, Jerry? Emma, make sense? Each triangle is an equilateral triangle. You can actually see it, right? They look very much like one, okay? But how to prove it? To prove this, we just use those degrees. So think about this, guys. Let's think about the middle part. If you go around, that's 360 degrees, right? And obviously here they are all symmetrical. So you have 1, 2, 3, 4, 5, 6. 6 inner angles, whatever you call it, right? So you do 360 divided by 6. Each angle is 60 degrees, right? Okay. And then we can look at this part. That's one of the interior angles in a regular hexagon. How do we know the interior angle, the measure of interior angles in a regular hexagon? Anyone? How do we find angle?
180 times 6 minus 2.
Very good. That's the sum of interior angles. To find one of it,
Divided by 6.
there we go. Very nice. Okay. So here we get 30 degrees times by 4, 120 degrees. Okay, Emma, Albert, that makes sense, right? Emma, 没问题吧？内角和除以几个边，几个边就几个内角嘛，对吧？一除就是每个内角的度数啊。So one of the interior angles is 120, and again, they divide. So this is 60, and the other is 60. And it goes with the other angles. So every angle is 60, you see? So 60, 60, 60, equilateral triangle. Okay, so just a very simple property of regular hexagon. So if AD is 16, then that means AO is 8, OD is 8, every side is 8, 4 times 8, sorry, 6 times 8, 48. So the perimeter is 48, okay? Any question? 好，Emma，你这个要记住啊， 个六边形，正六边形一分就是6个正三角形啊，6个这个等边三角形，正三角形。OK，good. Next. 1140. 1147 is a little bit hard, but everyone got it. That's really nice. So I'm very happy to see it. Okay. 1148. 1148 is a hard question because it's about that triangle or triangular inequality again. Okay. So before we see that, what is the triangular inequality? Does anyone remember? Triangular inequality. No one remembers?
A plus B must be greater than C.
Exactly. It's very simple. Very simple idea. The sum of any two sides of a triangle must be greater than the third. Right, Jerry Emma? Because if it is not greater, if it equals, you just have a flat line, right? If it's less than, it's not even a flat line. Okay? Yeah, the sum of two sides is greater than a third. And there's more to this. Because when you say the sum of two sides, we didn't specify which two, right? We didn't specify which two. So it could be this, and it could be this. Does it make sense? You didn't specify which two sides, right? So any two sided, we said, the sum of any two sided is greater than the third. So if you, by the way, this inequality, albeit very easy, in the future you will, you will use it, okay, in some questions. And in some questions, you maybe have to use it 3 different times, like this, okay? Make sense? Okay. So remember this, and when you need to use it, sometimes you need to use it 3 times, okay? But but I want to say that if you're gonna use it 3 times every time, obviously it can be very difficult, especially for questions that are very difficult, right? So you can only use one of them. And if you can tell which side is the longest side, okay? Think about this. Let's say C is the longest side, okay? If you know which side is the longest side in a question, if you don't know, then that means you have to do 3, right? If you know which side is the longest side, you just need to make sure that A plus B is greater than C. You don't need to do the other 2, right? Because, well, C is the longest. If C is the longest side, doesn't really matter, right? A plus C is definitely going to be B. I mean, C alone is greater than B and A, right? So if you can figure out which side is the longer side for triangular inequality, you just need to do 1. The sum of two shorter sides is greater than the longer side. Does it make sense? So sum of the two shorter sides is greater than the longest side, okay? Longest side. So that you don't have to do 3 of them. You just need to do 1 of them. And in this question, you will see that it's going to be very helpful, okay? Any question? 我再解释一遍 Emma，我怕你没有听完全清楚啊，再说一遍啊。三角不等式，这个中文叫三角不等式啊，非常简单，叫做三角形的两边之和要大于第三边。很明显，这是三角形成立的一个最基础的一个不等式，对吧？但是我们没有说是哪两条边，所以正常来说呢，那你就把所有的可能列出来嘛，对不对？这 A 和 B 比 C 大，A 和 C 比 B 大，B 和 C 比 A 大，对不对？这个三角不等式虽然看着很简单，这个以后啊。有很多一些就是哪怕高年级的题，12年级竞赛的题，它有可能其中一步会涉及到，然后呢，你就得做3个不等式分别讨论，这样比较复杂，对不对？但是如果你能知道你的最长的边是哪一个，不管是题目告诉你了，还是你自己想出来了，你已经确定了最长的边，比如说就是 C 边的话，你就只用做一个了，因为你只需要确定2个短边比最长的边长就行了嘛。对不对？假设 C 是最长边的话，你像后面2个根本不用管啊，因为 C 本身都比 B 和 A 大了，你再加个 A 和 B 肯定还是大，是没有任何去确定的必要的，没问题吧？你只用确定第一个成立就可以了。OK，so Jerry Albert I know maybe you don't fully get what I meant. Okay, I'm just saying that in some very complex questions, you might need to use this. Okay, in some even in AMC 12, many hard competitions. Okay, you might still need to use this occasionally. When you use this, you need to do 3 different cases, and that's very, very difficult, right? But for some reason, if you know the longer side, you can only do one. That's my point. Okay. And you will see this point in this question. Okay, so let's have a look. Okay, what did it say? Okay, so you guys can read it. I'm gonna give you just half a minute to read it, so you can remember what it means. Okay, so basically we have 3 sticks, 9, 12, 14 inches. Terry, so she is gonna cut off the same amount of each stick. And after she cut off that same amount, she can still make a triangle. Sorry, she's no longer to make a triangle. She's no longer able to make a triangle in the end. What is the smallest amount she can cut off? OK，那么没问题吧？题90、24一起呢减掉一个同样的 amount，减掉一个同样的长度。减完之后呢，这剩下的3根 stick 就不能变成个 triangle 了。它们至少减多少？Any idea, guys? What is the first step? Just give me a first step, guys. The first step in most of the questions, guys, is to get an x, right? To set x, to let x, okay? So if you think you can set x, you let me know. Can we set x here? And if we do, if we
Is it
can,
like 9 divided by x, 12 divided by
divided by? If you cut some amount off from each stick, are you doing, say you cut 3 inches off each stick, do you do a division or do you do
subtraction?
Subtraction, right? Okay, Jerry, am I right? Okay, it's always gonna be like not always, but 95% of time when you need to know something, you set it to be x. Okay, especially when we are getting to the end of pre-algebra. This book is pre-algebra, right? But we are at the end of it. That means basically every time we cannot suppose x. Okay, supposing x is algebra, all right? So when we get to algebra, we'll learn it. But yeah, it's the end of a book. You guys will learn algebra pretty quickly, pretty soon. Okay, so set x. Okay, guys, always remember set x. I see that Jerry, Emma, and Albert sometimes you forgot to set x, right? You always set x and have a look. Okay. So this so-called same amount is supposed to be x, and since you're cutting it off. You're doing a subtraction. So be clear what you're thinking, what you're doing. Okay, you're not doing division. So the 3 sticks are gonna be 9 minus x, 12 minus x, and 14 minus x inches. Correct? And what do we know? We know that with these 3 sticks, we are not able to make a triangle. Since you're not able to make a triangle, what is a triangular inequality here? So here comes what I just discussed here. In applying the triangular inequality, you need to test 3 of them, right? So do we need to do all 3 of them here? Or as I just mentioned, if you're able to identify which side is the longest, then you can only just do one, right? Do we know which side is the longest here? I think it's pretty obvious. Which stick is the longest?
Fourteen minus x.
Right. Jerry, Emma, that makes sense? 14 minus x is obviously the longer side here, right? All three quantities are x less than 9 and 12 and 14. So of course 9 like the first one has to be the smallest side, and this has to be the longest side, right? Emma 有没有疑问？对吧？是不是明显的看出来14减 x 是最长的边啊？对吧？ Okay, Jerry, make sense? And this is very important because it saves you a lot of time, okay? So this is the longest. So in this question, if the question says they can be a triangle, then that means the sum of the two shorter sides should be longer than the longer side. It should be 9 minus x plus 12 minus x longer than 14 minus x. This is the condition for a triangle, correct? But it says not a triangle. That means what do? We change it to what? If it is longer, that means we have a triangle. If we don't have a triangle, how do we change this condition into? What do we do? What condition here will make a triangle impossible? Okay, it's very simple, guys. The sum of two shorter sides is greater than the longer side. That's a condition for a triangle, right? This means we have a triangle. If you don't have a triangle, what is the condition here? Think about the triangular inequality, guys. Triangular inequalities, A, B, C, right? If A plus B is greater than C, you have this. But A plus B, if it's equal to C, you don't have a triangle. You just have C, this is A, this is B, just a flat line, right? And if A plus B is less than just the longer side, then this is C. Say A is only here, B is here. There's no way to make a triangle. B can be here, A is here. See? Not enough to make a triangle. Jerry, Emma, make sense, right? It's very simple, straightforward. Which means that the sum of two sides, if it's less than or equal to the third side, there's no triangle. Right? Basically the opposite of the condition where we have a triangle. Does it make sense? Okay, think it, right? The triangle. When you have a triangle, the sum of two sides is greater than the third. And then if the sum of the two sides is not greater than the third, in other words, less than or equal to the third, you don't have a triangle. Does it make sense? Does it make sense? Albert? Emma? 没问题是吧？两边值和大于三边真角形吗？不到就是没有吗？那这道题如果要没有怎么办呢？ What if it doesn't have a triangle here? How do we change this condition into? We literally just said it, guys. Anyone? The sum of two sides, if it is greater than the third, you have a triangle. If it is, again, less than or equal to the third, you don't have a triangle, right? So it's basically the opposite of this condition. So we wipe this out, switch it, less than or equal to, right? The sum of two sides is less than or equal to the third side. You don't have a triangle, correct? Jerry, make sense? Emma, make sense? Okay, 看看有没有什么疑问啊？ Right? The sum of two sides is less than or equal to the third, okay? And that will give you the solution. And again, why do we choose these two sides to be the sum? Because that's the longer side. So you only need to test one, okay? If you don't know which side is the longest, you have to test three of them. Do you guys see that? Because we know this side is longest, we just need to test this, right? If you don't know which side is the longest, you have to try, say, the other, say, the sum of the other two sides is going to be less than or equal to the third side. And you're going to try the sum of the other two sides. See, you have three possible inequalities to try. Does it make sense? If you don't know which side is the longest, okay? But you know which side is the longest, you only need to try one. In other words, the other two wouldn't give you any solution because you're trying to get the longer side less than, doesn't make sense, you see? The longer side couldn't be less than the shorter side, right? So even if you try, it won't work. You just get no solution. Does it make sense? Okay, good. Emma, 觉得明白吗？我这边强调啥？最长的边啊，要想明白，对不对？因为你两边之和大于第三边，如果你把最长的边放在两边之和里，那肯定不可能就是说小于第三边嘛，因为它已经是最长边了，对不对？你最长边还得要加一个边，怎么可能比短的边还要短呢，对吧？根本就不用试啊，你只用试这一组，叫做两个短边小于最长边就可以了。这个是你能找到最长边啊，如果找不到最长边，你就得把三个全试一遍，那就比较难了。那一般就是说，至少也得是个10年级以上的竞赛，它才会有考到这是比较复杂的情况啊。Okay, so basically we just need to solve for this. So we get, oops. Yeah, so we get 21 minus 2x less than or equal to 14 minus x. So you move x over here, move that over there. X is greater than or equal to 7. Done. So the smallest will be 7, right? Obviously, x is greater than or equal to 7. Okay, guys, make sense? And you can test the answer. If x is 7, we get 2. 5 and a 7. You see, 2, 5, 7. 2 plus 5 is 7. You just have this is 7, this is 2, this is 5. No triangle. And that makes sense. You see, that's actually the threshold of not having a triangle, right? That's like the mark, the border, the line between having a triangle and doesn't have a triangle, right? 没问题吧？看吧，你看，当 x 等于7的时候带进去，刚好是一条线，说明这刚好是临界值嘛。比这略大一点，它就可以是三角形了。对吧？比这类小一点呢，连一条直线都没有，对不对？刚好是一条直线，right？这说明我们答案肯定是对的啊。You can also test for 3 if x, sorry, test for 6. If x is 6, that's 3, that's 6, that's 8. See? 3, 6, 8. 3 plus 6 is greater than 8. So that means you have a triangle, 3, 6, 8, okay? Yeah. Any question, guys? Okay, the takeaway message, guys, identify the longer side, use triangular inequality. Okay, if it says a triangle is not possible, less than or equal to. If it says we have a triangle, greater than. Make sense? Greater than means you have a triangle. Less than or equal to, you don't have a triangle. Okay. Very simple diagram here. Okay. Oh, what happened to my? Okay, let's move on. So, okay, I'll move on to. I'll leave these two for the next class then, because I want to do some more chapter 12. Okay. So 12.1, we haven't finished it last time, right? I remember we only did like one of it. Yeah, we did this. We only did 12.1.6. Yes. That's a Pythagorean triple thing. Yeah. Okay, we need to do 12.1.5 and the other ones are fine. So So here we have a square, a rectangle, a right triangle, and a semicircle combined to form this figure. Find the area of the whole figure. Okay, does anyone have any idea? Emma，你没有，这是你没有做的，我印象中如果没错的话，你看看怎么做啊？现在我觉得应该会做了吧才对。我看看第二次做。 对，Emma 没有做好。来，Emma 试试，快，你看有没有什么 idea？还是 means goal analysis 啊？Again，你告诉我你想要什么，然后怎么去做到。你就先讲你要什么，你这里缺什么，你要找面积哈，对不对？你现在已经
对
知道了什么和不知道什么啊？来，
已经知道了，就是正方形的4个边多
对，
长，
你现在这个正方形面积会求了，对吧？长方形可以求吗？
长方形也可以
也可以
求
求了，所以你要求的是这俩，对吧？
啊，
嗯，
对，
那你看看三角形能求吗？
三角形也可以求，
也可以求，因为16、12都有了，所以其实主要就求个圆，对吧？
对，
那这个半圆你如果要求的话，你需要知道什么
它的半径，
啊？它的 radius 非常好，在这个图上 radius 哪里可以看到？
嗯
这如果是个半圆的话，你能看到 radius 吗？如果找不到 radius，找 diameter 也可以啊，对不对？diameter radius 一样的东西嘛，对吧？有没有 diameter 呢？
那就是三角形的那条边，
对，AG，right？那 AG
对
diameter 我中间分一半不就是 radius 吗？其实就是在找这个值。那其实把 AG 找到除以2，这不就可以了？那 AG 能找到吗？
难，
那16、12肯定能，对不对？16、12，它的 AG 多长？这个可是 Pythagorean triples，有没有印象啊？
嗯，有点忘，
不是有点忘，是确实没有背过。为什么呢？因为它是一个 Pythagorean triples 的 multiple。
嗯
因为我们可以看到12跟16都有一个叫什么？有一个 common factor，right？
嗯
12、16的 common factor 是几啊？
12、16的 factor，
嗯，它们都是谁的倍数啊？
4，
对，很简单，对吧？所以一个是4
嗯
乘3，一个是4乘4，right？那都是4倍的话，你是不是只用看这个4跟3呀？
是
3、4，所以 AG 应该是 Pythagorean triples 3、4节，不记得，不3、4、5嘛，对不对？勾三股四选5没听过吗？对吧
嗯
？Pythagorean triples 3、4、5嘛，right？所以3、4 AG 是不是应该是5啊？OK，但是它毕竟是乘了个4嘛，再乘一个4就行了，所以你 AG 就是20，make sense 吗？12、16、20，12、16、20就是3、4、5这一组的4倍。别忘了，你有 Pythagorean，就是只要有3个数，它满足 Pythagorean theorem，它的多少倍都满足，你印象吧？我们讲过这个啊，上节课对不对？所以你看到12、16，直接就是找它是几倍，因为很明显它们有 common factor，这个4一拿出来，3、4就知道是5，4、5、20，AG 呢就是20，OK？那
嗯
么 radius 就是10，对吧？那上面半圆就出来了，最后全部加起来完事儿了吗？
嗯
现在会了吧？之前卡在哪儿了？
之前可能没有
没看到？
算清楚吧，就是
你看出来 AG 这边是它的 diameter 吗？
嗯
看出来了。
我就
你看，
是单纯算三角形上面，就
哦，
是弄得有
那你
点乱。
那就实在是没办法，就是12、16直接用 Pythagorean theorem，对吧？但是这肯定是不推荐了，你一定要会我们讲这个方法，好吧？这个方法我们上次练过啊。OK，good，all right，Jerry Albert, I'm not sure if you guys have any more problem about this. Okay, so you see means goal analysis, right? You see what your goal is and you see what your means are. So square is what we know, rectangle is what we know, and you move the 16, move the 12 over here. Triangle is what we know. We just need to know the semicircle, and that means you need to do the radius. Okay, and it's very common that well to see that AG here is that diameter. This is a very common diagram. Okay, AG is the diameter. That's something you need to realize. So to find a radius, just half of AG. Okay, so the half of AG, you have 12, you have 16. How do you find AG? Pythagorean triples. Always remember, you're going to use Pythagorean triples, especially when you see a common factor here. Okay, 12, 16 common factor. You factor it out. use the so-called like base number 3, 4, which they're relatively prime. They don't have any common factor, okay? And use the 3, 4 to figure out the 5, time the 4 back, and you can find the radius. And then you can find the area. Okay, Jerry, does that make sense? Does that make sense? Recall that the triple thing, right? So if you have a squared plus b squared equals to c squared, then n times a, n times b, n times c will also be Pythagorean triples or Pythagorean numbers like this, okay? If you have this, then this must be true. You can see that from law of exponents. We demonstrated this before, right? Basically, just open up brackets and divide by n squared. There we go. Okay, Emma 没问题吧？你看倍数也可以啊。Okay, so this is very common. Last time we did this question. Let's just see it again. This, right? If you know the legs, very big numbers, right? But we can obviously see a common factor here, which is 10,001 times 7, which is 70,007, right? That's the common factor. Get it out, and you will get 7 and 9 as their so-called basic numbers, okay? And use the basic numbers, Pythagorean theorem, you get square root of 130 and time this number back, okay? It's a very common strategy, especially when you don't have a calculator. Emma， 你看这道题，上节课讲的还记得吧？虽然原数非常的大，但是能看出来7007是 common factor，拿出来之后，把剩下的7跟9做一个 Pythagorean theorem 就可以了啊。然后再把这个7007乘回去，对不对？没有疑问吧？好，一定要学会把这个 common factor 找出来，然后做 Pythagorean theorem，好吧 ？Okay, good. Let's move on. So 12.2 is about special right triangles. And we have some problems here. So let's see. Before we do these exercises, let's review a little bit. There were 2 types of special right triangles. Can anyone tell me which 2? Which 2 special right triangles? What 2 types? Anyone? What are the measures of the angles? Degree measures of the angles?
30, 60, 90.
Yeah, there's the 30, 60, 90 angle or triangle, and the other is isosceles. Okay, 45, 45, guys. What is the ratio? Say the first one. What is the ratio of this triangle? The ratio of the side length. Jerry, remember? Emma, Albert? What is the ratio of the first one? Emma, 你记得吗？这第一个的 ratio 是多少？不记得了。那你也复习啊，Emma。你看你每次基本上学的，你都下节课英文都不记得，Emma 不行了，OK？ Yeah, Jerry, do you remember? No one remembers? Okay, the ratio is very simple to figure out. So let's talk about this again. So Albert, do you remember the ratio for this?
It's like s to s to the square root 3. S square root 3.
Oh, that's the other ratio.
Oh.
Yeah. Okay, so let's explain this again. For the first one, the ratio is very simple. You have 45, 45. That means it is an isosceles triangle, correct? Isosceles, so if you do ratio, obviously it's 1 to 1. You can just suppose the side to be 1. Because you're doing ratio, right? Doesn't matter, just suppose the side to be 1. And with 1 and 1, use Pythagorean theorem. So the hypotenuse is square root of 1 squared plus 1 squared. It's very easy to get root 2. That's it. You see? 1 to 1 to root 2. Isosceles. So you get 1 and 1, and the root 2 thing is just Pythagorean theorem. Does that make sense? Right? Why can't we just set it to be 1? Well, setting it to be 1 is the same as setting it to be x, by the way, guys. It's a ratio problem, so you can set them to be any number you want. If you set them to be x, your hypotenuse would be this, right? X squared plus x squared taking a square root. That's square root of 2x squared. And that means you have root 2 and x squared, right? X squared square root is x. So in the end, you get x to root 2x. You divide by x, you get the same ratio. Okay, so that means it works for any numbers. You can set it to be 2, 2 and 2, that's root 8, that's 2 root 2. See, 1 to 1 to root 2. If you set it to be 3, 3, 3, that's just 2 root 3. I mean, 3 root 2 is just going to be 1 to 1 to root 2. Okay? Any question? Let's look at the other. What is a ratio here? And how do we work it out? The way to work it out, does anyone remember? Is that going to do a reflection? Okay? It's in a textbook as well, Jerry Emma. All right? So if you don't remember, you want to read the textbook again, okay? I'm basically just showing what the textbook is did. So you flip it over this longer AC side, then you get this, right? You get a copy of it down here. Remember? When you flip it, this is going to be 30 degrees. This is going to be 60 degrees. Everything is the same, right? The two triangles are exactly the same. Let's say this is D. Then you know that BC equals to CD because you flip it. They're symmetrical, right? Okay, in that case, you can suppose BC to be 1. That means CD is 1. And that means BD is going to be 2. Okay, and the triangle ABD, this entire triangle is an equilateral triangle. Again, see, all three angles are 60 degrees. So it's an equilateral triangle. And that means AD is 2, AB is 2. Okay, now if you wipe out everything, wipe out these reflections, you see, you get 1 and 2. BC is 1, AB is 2. See if that makes sense? One and 2, okay? And to figure out the third side, use Pythagorean theorem. Root 2 squared minus 1 squared. 4 minus 1, 3, root 3. So the ratio is 1 to root 3 to 2. Okay, Jerry, make sense? Yeah, Emma? We did go over this last time, okay? Everyone said it makes sense, but you're gonna review this and remember this, okay? Just understanding it is not enough. You have to remember what we learned, okay? And use it in your homework. So Emma, I didn't see you use this in your homework, okay? Yeah. For this ratio, last time I mentioned this as well. This ratio is very easy to get wrong. The first ratio is I don't see anyone apply it in a wrong way. Why? Why is the second one more prone to errors? That's because in the first one, you just have 1 and root 2. So the two legs, they are the same, right? It doesn't matter which leg is the one. I mean, both are the same. And obviously, the longer side, this root 2 has to be that hypotenuse. So everyone gets it right, okay? In the second triangle, guys, second triangle, Emma, Jerry, Albert. In this second triangle, it's very easy to get it wrong. Why? Because the two legs are not the same. One is 1 and the other one is root 3, right? It's very common for students to mess them up. Because if you say you have a triangle here, this is 30, this is 60. Yes, everyone can remember it's 1 to root 3 to 2. And since 2 is the longest, everyone knows that 2 is the hypotenuse, right? But what about 1 and root 3? A lot of students mess them up. They think maybe 1 is here, root 3 is here. Then that's going to be wrong. Because 1 is actually here, root 3 is here. Okay? With the diagram, maybe you can see it because 1 is the shorter side, root 3 is slightly longer, right? But what if we don't have a diagram? If we don't have a diagram, we will draw a diagram, we will sketch it. I mean, maybe a sketch like this, maybe this is 30 degrees, you see, you actually sketch it wrong, and you maybe think this is root 3, that's wrong. This is actually 1. Does it make sense? Okay, I'm explaining why the second ratio can be mistaken. You can make mistakes on the second ratio a lot. Okay, if you didn't remember how to assign the ratios. Okay, so how do we remember? How do we counter this error? Last time we mentioned this. Okay, the strategy is always to find this 30-degree angle. Okay, once you find a 30-degree angle, you go to its opposite. That's the one. Always remember this. You find a 30-degree angle. Doesn't matter what the diagram looks like. The diagram can be out of scale. Okay, but you always find your 30-degree angle, go to the opposite. That's the one, and the hypotenuse is a 2. In other words, BC is half of the hypotenuse. Make sense? BC is half of the hypotenuse. Okay. So if I have a, say I have a diagram like this, it's just a sketch. So maybe this is 30, 60, you see? I didn't sketch in scale. Obviously, 60 degrees should be twice that, but I didn't sketch it well. Okay, guys? But it does not affect your ratio. Even though this bottom side looked bigger than the other side, the bottom side is still gonna be 1. And this side is 2, and this side is 3. Even though on a diagram it doesn't look like it. Because the diagram is not drawing in scale. The diagram is out of scale. Make sense? How do we know that? 30-degree angle, opposite, 1. And then hypotenuse 2. Now you know the other side has to be root 3. So I'm gonna write this down. You guys must remember this, okay? Must. Because a lot of students make mistakes. I don't want you to make mistakes. And this is the best way to not make a mistake, okay? So the side opposite to the 30-degree angle is 1/2 the hypotenuse. Okay, hypotenuse, I'm gonna write this down, okay? Hypotenuse. Always remember this, okay? In any triangle, any diagram, you find 30-degree angle, find its opposite side. Its opposite is 1/2 the hypotenuse. Sometimes you might not be able to find the 30-degree angle, but you can find a 60-degree angle. So once you find a 60-degree angle with the right angle, or the other side, the other angle has to be 30. Okay, so find the 30-degree angle and find the opposite side. That way you don't make mistakes. Any question, guys? Any question? Okay. And let's do these two. This is the first problem. There were 3 diagrams. First one doesn't have a problem. This is the second and third diagram. Okay. Let's work on the second one. So in this question, since angle U equals to angle V, everyone knows this is also 20, okay? But the problem is, what is UV? Anyone? So Emma, we didn't do this. Let's try again, okay? Because this is Pythagorean triple again. Let's look at this triangle, TMV. That's a right triangle, correct, guys? So that means with 20 and 16, you can figure out MV. So what is the length of MV? Anyone? 2016。Emma，来，你做一下，我想练一下。这个又是刚刚的 Pythagorean triple，记得吧？有倍数的关系，20、16嘛，对不对？你试一下。怎么去找那个边啊？我们刚刚说勾五定理就是 Pythagorean theorem 要用的时候，一定要看它们是不是哪个数的 multiple 嘛，对不对？要找 greatest common factor 嘛，对吧？那你说这个地方怎么找啊？这个20跟16啊，对不对？
它们都是4，
对，那你告诉我他们都是4乘几？
4×5，然后4×4。
嗯，所以我们看谁？看哪个数？如果找 MV 的话，看哪个数？
嗯，
它们都是4倍的谁啊？一个是4倍的5，一个是4倍的4，所以看谁啊？这个4是倍数对吧？另外那个4跟5就是它们的边长，对不对？是不是最基础的边长啊？明白吗？
是。
所以是不是看这个4还有这个5啊？
嗯。
有4跟5，说明另外一个边是几？
6。
3 4 5，别忘了。对，你可以想嘛，3 3得9，4 4 16，9加16 25，看到没有？3 4 5是不是最简单的，符合这个勾股定理的数啊？不是6，3 4 5嘛，对不对？所以 MV 这个边是不是应该这个基本的数应该是个3啊？对吧？然后乘以几倍？4倍，非常好。所以答案是不是12MV？它是12，那另外一边也是12，记得不？这不就是那个刚刚我们画了个三角形的那个 case 吗？这2个三角形是一样的嘛？很明显，右边的三角形翻过去是左边的，因为你看边长全一样，20、16啥都一样，角也一样，边也一样，角也一样，肯定是同样的三角形，明白吧？所以2个都是12，最后 UV 这边就24，会了吧？你看20、16就这么找，现在会不会了？刚刚不就是个吗？12、16、20，刚刚那道题对吧？所以这种非常常见，就是3 4 5还有3 4 5的倍数，什么6、8、10啦，对吧？9、12、15啦，12、16、20了，这非常常见啊，在这各种题里面。OK，好吧，Okay, Jerry, Albert, any question about this? I think that should be fine, right? 2016 and stuff. Okay, the other shape. What do we do here? Jerry, do you want to try? No? It's okay if you don't want to try. I think Albert got it right. Yeah, I think Albert got it correctly. So, Jerry, Emma, anyone? Yeah, Jerry, what do we do? You have no idea? Okay, so Jerry, Emma, the idea here is, first of all, this is nothing, right? So you're gonna first try to divide it into some shapes, but before you do that, you see we have 2 equal sides, so you can first label that QR is 14, okay? But to figure out the other side, obviously you have to divide into two shapes, right? How do we divide it?
S to Q?
To this? Okay, if we do S to Q, what is if you like triangle PQS, that's not a right triangle. You have 120 degrees, and then you don't know this, you don't know this either. You don't have enough information, right? On the other side, that's a right triangle. You know this is 14, but you don't know this, you don't know this. You don't know if they're a special right triangle or not, right? You don't know.
And
And you don't know this.
PQR?
Yeah, so there's nothing we can do. Okay, good. So we try another. If we try PNR, this is a right triangle, good, but still no degrees, you see? No degrees. So it looked like the top is an equilateral triangle, it looked like so. You couldn't be very sure, but we did
But we can find angle P and angle R.
yeah, very good. Okay, so if you know that yeah. So what is angle P and angle R?
That's 60.
Hmm,
The other side 60.
very good. Very good. Yeah. So if you know this, yeah, this way works. You see? So you're gonna give it a try, right? Sorry. Yeah. So that's why you're gonna try. You try SQ, didn't work, then you can try PR. And it actually worked. Okay, so Emma, Albert, does this make sense? If you connect PR, then PQR is an equilateral triangle. Okay, Emma, 你明白为什么吗？为什么呀？Emma，明不明白？明白你就说一下，不明白我给你讲一下。Emma，为什么这上面能知道是2个60度啊？刚刚这个 Jerry 说的，
因为
为什么？
它是等腰三角形。
等腰，然后顶角60，对吧？非常好，very good，OK，Jerry，very good。So what's next? Let's label this 14, and then
On the right angle on the right side, the other side is 30 degrees.
very good. And this
And
is
the-
also 60.
Yeah. So angle S is 90.
Yeah, angle S is 90. Very good. So now we can know that this is actually a special right triangle. And then we can use our ratio, right? What did we just mention when we have something like this?
Also, side PS is 7. That's revealed.
Yeah, very good. And 14 and 7, what is SR?
SR is the altitude of PQR.
Yeah, it is the altitude, but you can use the special right triangle. Use the ratio thing. What is the ratio in PRS?
1 to 2.
Yeah, 1 to 2. Which side is 1? Which side is 2?
SP is 1. PR is 2.
And what is the ratio of the other side?
Square root 3.
Square root 3. Good. So, Jerry, remember? 1 to root 3 to 2. So, Jerry, if you remember 1 and 2, you should remember root 3 because with 2 and 1, it's just a very simple Pythagorean, see? 1 and 2, 2 square minus 1 square root 3, right? Okay. So the ratio for SR is root 3, and that means what is its side length? 1 to 2 to root 3. The actual length, 7, 14, and what?
7 square root 3.
7 square root 3. 7 root 3. Jerry, see if that makes sense, right? Because the ratio is 1 to root 3. That means SR is simply just root 3 times SP. The ratio is 1 to root 3, right? So for every 1 in SP, you have a root 3 in SR. So if you have 7 there, 7 times root 3. Make sense? Okay, good. That's how we use everything. All right, I'll review this again for Emma. Okay, so Emma, so this is a good way to do it. We connect PR, we find it's an equilateral triangle, and then Emma, you say, this is 60, that's 90 for angle R. So this part is 30, right? For the other part, that's 60 and 120. So the other part is also 60. With 30 and 60, we know S is actually a right angle. So that means PRS is a special right triangle. Let's draw it here. It looks like this, PRS, right angle, 60 degrees, 30 degrees, and we know PR is 14. Okay, guys? So Jerry, I also want to do this ratio thing for you again, and so that you remember what to do in the future, okay? Our key step, actually my step, right? The method I told you guys. You might learn other methods from other teachers, but I want you to use mine. I mean, it worked really well, okay? What you do is that you first find this 30-degree angle, right? Find its opposite. That's 1/2 of the hypotenuse, so that's 7. Once this is done, you can actually find the other side using Pythagorean theorem or whatnot, okay? But if you use ratio, that's the simplest because the ratio tells us it's 1 to 2 to root 3, right? The meaning of 1 to root 3 is simply means that you're going to time by root 3, right? From 1 to root 3, time by root 3. So you time this 7 by root 3, 7 root 3. Done. You time the 7 by 2, you get this 2, 14. If you know this 14, know this 2, you can divide by 2, you get this 1, time the root 3 to get the other side. That's how we use the ratio. That's why ratio is very helpful. Okay, Jerry, Emma, that makes sense? Okay, Albert, that makes sense? 1 to root 3 to 2. Okay. All right. Even if you don't use the ratio, we can still figure out this 7 root 3 very quickly because we have 7 and 14. That means they're both multiples of 7, right? So one is 1 times 7, the other is 2 times 7. So they're both multiples of 7, right? With 1 and 2, you will know that, oh, well, 2 squared minus 1 squared is 3. So that's root 3. Again, you time by 7. So this side is 7 root 3. And this is the method we have been using in these chapters, right? Okay, so you can use ratios or you can use this。那么有没有问？所谓的对吧？1比根号3比2，就是你把1找出来了之后，乘以根号3乘以2就出来了嘛，对不对？OK 吧？ Jerry, okay? 1, 2, root 3 to 2. So that's why I always want you guys to find a 30-degree angle. That means you can find a side that is actually 1, and you time by root 3 is here, you time by 7 is here. Oh, sorry, time by 2 is there, right? 1 to root 3 to 2. Find the side that is 1 and time by root 3 and time by 2. You can find the other two sides. There's one more solution, one more way you can do this, guys, which is also pretty common. So I want to introduce that, which is so Jerry, okay, you can also do a perpendicular thing here. Let's say this is T. Okay, Emma, Jerry, you can also do this because this way will allow you to have a special right triangle again. And that means this is 90, that is 90, that is 90, 3 90s, so S is also 90. So this is 14, right? They're equal. And again, PQT, 30, 60, 90. You find this 30-degree angle, find its opposite side. Opposite side is half the hypotenuse, so that's 7. Right? Half of 14, 7. Done. And the ratio is 1 to root 3 to 2. This is 1, this is 2, and this is root 3, right? 1 to root 3 again, you time by root 3. You get 7 here, you get 7 root 3 here. And you get 7 here, you get 7 root 3 here. Okay, same answer. And this is also very common, okay? Emma, Jerry, make sense? So turn out it is actually trapezoid. In a trapezoid, do this, you get it, you basically divide this into a right triangle and a rectangle. It's a very common strategy. Okay, something you need to be aware of. Okay, Jerry? Emma? Okay? Yeah. All right, that's pretty good. I guess that's all for today. For this part, you guys can keep doing it. And the homework is to preview 12.3 and just finish 12, okay? 12.3 only is also pretty simple, just types of quadrilaterals. It has some definitions and stuff. So I want you guys to read them first before we talk about these, okay? You just read this part. You just need to know what is a rectangle, what a square is, what a rhombus is, what a parallelogram is, okay? So read it and do some, and just do those example problems and exercises, and that's chapter 12. So I also want you guys to finish chapter 12 review and challenge, okay? Next time we're gonna go over quadrilaterals, go over some things, then we can move on to 13. 13, starting from chapter 13, we are done with the geometry. So 13 is just data and statistics, very simple ideas, very simple questions, okay? 13 is very simple, but 14 can be challenging. Chapter 14 and 15, they're challenging. And after that, we finish this book, we will study algebra and geometry, like real algebra and geometry. Okay, these geometry are way too easy. It's very fundamental, okay? All right, okay. I'll see you guys next week. Thank you.
Thank you.